Hi, dear students. Now we're going to continue solving exercises with polynomial functions. In this case, they are giving us the polynomial function, and we have to answer different questions, 4 questions. Later on, I'm going to show them to you. Look, here the polynomial function is f of x equals x to the second times x minus 2 to the second times x plus 1. They are giving us the function in factored form, okay? So, first of all, look, the first question is, choose the end behavior to the graph of x. And remember, the end behavior is how the graph is ending to the left and to the right. So, we have to get which is the degree of this polynomial, so we can check, and also which is the sign of the leading coefficient. So we could find which is going to be the behavior to the left and to the right. Remember? First, how are we going to get the degree of this polynomial? We are going to multiply the x terms that we have here in the original function, which is x to the second times x, but this x is being raised to the second because of this uh, power, and then times this other x, but this x is being raised to the 1 power. So check, here I have the product. So we have x to the second, which is this one, times x to the second, which is this other x raised to this second power, times x, which is this x being raised to the 1 power. So x to the second times x to the second, x to the fourth times x, this is x to the fifth. So, and then here we found that the degree is a fifth degree, which is an odd number. And then we are going to look for the sign of the leading coefficient. And we're going to multiply the coefficients of all the x terms. So here we have 1, positive 1, times positive 1 from this other x is positive 1 anyway. Then we multiply by this other coefficient, which is also positive 1. So in the end, we have positive 1 as the leading coefficient. As the leading coefficient is positive and the degree of the polynomial is a fifth degree, which is an odd number, the behavior is going to be this one, dear students. Remember, it falls to the left, the graph falls to the left and raises to the right, okay? So you have to select this option in ALEKS. Then let's continue with question B. And look, it says, list each real zero of f according to the behavior of the graph at the x-axis near the zero. If there is more than one answer, separate them with commas. If there is no answer, click on none. Remember that when we have a root that do not appear in the x-axis is because this is a complex number root. But here, we're going to find just real number roots in this example, okay? Now, let's see. We're going to take the factors that we have here in the original function, and we're going to rewrite them here. Remember, we're going to take each of the factors and we're going to equalize each of them to 0. So we have x to the second, which is this one, the first one, equals 0. And then we have x minus 2 equals 0. But just pay attention. This x to the second and this x minus 2 raised to the second power, that means that the multiplicity of these two factors is 2. That's why when we solve for each of them, as you can see here, when we solve for x to the second equals 0, we get x equals the square root of 0, and in the end, x equals 0. But the multiplicity of this factor is 2, okay? The multiplicity of this root, sorry. Good. And then the other one is x minus 2 equals 0. We solve for x, and we get that x equals 2. And the multiplicity of this other factor is also 2, because this factor is being raised also to the second power. And as you can see, x plus 1, which is the last factor, is being raised to the 1 power. So the multiplicity of this root, the root that we are getting here, is 1. So we have x plus 1 equals 0, and we get that x equals minus 1. The multiplicity of this one is 1. Okay? So as you can see, As the degree of this polynomial is a fifth degree, we have to get 5 roots. And this is what we are getting. 2 roots here, which is in x equals 0. 2 more roots when x equals 2. So here we have 4 roots. And the last one, which is x equals -1. So we have 5 roots. Good. Now, let's see the third question, which is find the y-intercept of the graph of x. So here I am writing in pink color the original one, which is f of x equals x to the second times x minus 2 to the second times x plus 1. What we're going to do in order to get the y-intercept is to evaluate the function in 0. I mean, when x equals 0, and we evaluate it. So we are going to have f of 0 equals, instead of x, remember that we are going to substitute it by 0 because we are evaluating the function in 0. So we have 0 to the second times 0 minus 2 to the second times 0 plus 1. And then 0 to the second is 0. Then we have 0 minus 2 is minus 2. And we raise minus 2 to the second power. And then we have here 1. 0 plus 1, 1. Then we multiply all of them. 0 times -2 times -2, this is +4. So 0 times +4, 0 anyway, okay? And then 0 times 1, 0. So we have that the answer for f of 0 is 0. That gives us that when x equals 0, y is 0. So this is the origin. As you can see, the y-intercept is going to see exactly in the origin. Now, let's see. So you're going to write here the answer. The y-intercept of f. And here you're going to type that the y-intercept is in the origin. Now, graph. The last question, we have to plot the graph of the polynomial by doing the following, dear students. Look, plot all the points where the graph of f intersects the x-axis and the y-axis. Then, for each point of the x-axis, select the correct behavior, and then click on the graph icon. Good. First, I have here the coordinate plane with the x and the y-axis. I already have plotted here the points where we have the roots. As you can remember, here we have them. When x equals 0, and I have here 1 point in 0. Remember, the multiplicity of this root is 2. So we are going to have a bounce. Or in ALEKS, they say that the graph just touches the x-axis, okay? Or bounces. Then, when x equals 2, again, multiplicity of 2. So in 2, we are going to have again a bounce. So let's start. No, because I want to show you the behavior. It depends where the graph is coming from. And then x equals -1. So again, I have here another point in -1. So here we have the 5 roots. 1 in -1, 2 in 0, so 1 and 2, 3, and 2 in 2. So 4, 5. Here I have the 5 roots. And then remember that the y-intercept is also in the origin, as we have here a root. We just plot 1 point, because here we have 2 roots and the y-intercept. Now, as you can remember, in the first question, we found the behavior. It is falling to the left and also rises to the right. So that's why I draw these lines. It is falling to the left and it is rising to the right. Okay? So this is a good thing for you to do this. Draw the behavior of the endings so you could know where you are going to start plotting the graph. And then let me take the pen so I can continue plotting the graph. Okay, remember the multiplicity of -1 is 1. Let me show you. Here we have it. The multiplicity of the root -1 is 1. The other two, the multiplicity is 2. So this is the only one which is going to cross. It is not going to bounce. So -1, look, as in the left part of the graph, it is falling. I'm going to connect this with the root, the first root that I have from left to right. So it is going to cross, okay? Because the multiplicity is 1. When the multiplicity is an odd number, it could be 1, 3, 5, 7, and so on. It crosses, but it depends. For example, if the multiplicity is 1, just it as this one, it just crosses. But if the multiplicity is 3, it is going to flatten a little bit like this, but it crosses anyway. If the multiplicity is 3, for example. If the multiplicity is 5, it is going to cross, but it is going to flatten a little bit more, okay? Like this, more or less. If it is 7, it is going to flatten a little bit more, okay? So if the multiplicity yeah, is greater, it is going to flatten more and more and more, okay? But it is going to cross. And for example, let's continue with the next root. As the next root is 0 and the multiplicity of 0 is 2, it is going to touch or just bounce in the x-axis. But look, you are not going to bounce like this, okay? Because look, the graph is coming from this other point. So it is coming from here. So it goes back. Let me delete this one because this is not correct. It is not going to bounce like this, okay? It is going to bounce like this. Huh? Because look, it is the graph is coming from this side and then it returns and it is going to connect with the bounce that we have here in the 0 point. And then the root that we have in number 2 also has a multiplicity of 2. So it is not going to bounce like this because we have to connect it with this other part of the graph. So delete this one. It is going to bounce again like this. Careful because you have to see where the graph is coming from, okay? So we're going to connect these two like this, okay? And then as we don't have any other point, we just connect this bounce, this one with the end behavior, okay? And there we have the graph. As you can see, it is falling to the right, to the left, and it is racing to the right. And then where x equals -1, as the multiplicity is an odd number 1, it just crosses. Then it goes back, and in x equals 0, as the multiplicity is 2, it bounces, poink, okay? And then it goes back to the x-axis, and then as the multiplicity when x equals 2 is 2, it again is going to bounce or touch the x-axis like this, poink, and then it connects with the end behavior to the right, which is racing, boom, and it continues going to the infinity. Okay. Something important, dear students. When the bounce is an even number, like 2, the bounce is going to be like this. Okay, 2. If it is 4, which is also an even number, it is going to flatten a little bit more like this. And if it is 6, it is going to flatten more, okay? So it's the same thing as when it crosses. If the multiplicity is greater, the flatten is going to be like, it is going to flatten more and more and more. Good. Thanks for your kind attention, dear students. Have a very nice day. Take care, stay at home, and I love you.